Good morning, guys. So today we are starting something brand new. We're going to be talking about topographic maps for this week, and then next week we'll be getting into satellite views. And that's about understanding what the landforms and structures that exist on the Earth and how we can recognize them from a satellite view or a picture taken from space. But our job this week is to interpret topographic maps to identify land and erosional features and predict how those features can be reshaped by weathering. And you spent some time in seventh grade talking about erosion and weathering, and we'll review some of those things as we move through the week. So let's just specifically right now get into understanding topographic maps. So what is a topographic map? It is a two-dimensional model of the Earth's surface. So if we think about the Earth in its real form, the Earth exists in three dimensions, like we all do. But sometimes we have to represent the Earth in two-dimensional space, like on a flat piece of paper or on a flat map. So a piece of paper would be two-dimensional, up and across, whereas three dimensions is up, across, and out, right? So we need to find a way to kind of represent topography, which is the lay of the land, the hills, the valleys, the rivers. Is the land flat? Is it hilly? Is there a slope to it? Those kinds of things. So we have to figure out a way to represent those features on a flat two-dimensional map. So we want to represent a three-dimensional world on a two-dimensional space. So we do that by using what we call topographic maps, and they're also known as contour maps because they are maps drawn with what we call contour lines on them. And we'll talk about more specifically about what those contour lines represent. So those contour lines show elevation above sea level. And so those lines connect parts of the land that are at the same height above sea level, or what we call altitude above sea level. So for example, San Antonio is approximately 770 feet above sea level. So if we go down to the coast and drive from Corpus Christi, which would be 0 feet at sea level, up Out 37 to San Antonio, not only would we be traveling horizontally 120 miles or whatever it is, we'd also be going up 770 feet. And so for some perspective, that's about as high as the Tower of Americas in downtown San Antonio. So let's talk about what a topographic map represents. Okay. All right. So here we have a hill, and we have this hiker, and he's climbing up the hill, and all of those white lines represent how high above sea level he is. So as he travels up this hill, here he would be at 10 meters. Everywhere along this line, he would be at 10 meters. Everywhere along this line, he'd be at 20. So about right here, he would be, 15. And about right here, between 20 and 30, he'd be at 25 meters. Okay. So if we look at this slope, which is kind of a medium grade, and it also applies to like slope in math, you can see that his rise, okay, and his run. So how far he goes up and how far horizontally he has to travel to get there. Okay. So going from 20 to 30 to 40 to 50. Okay. These are what we call contour lines. Now this is profile, right? So this is looking at something from the side. So if you're watching somebody climb a mountain from far off, this is what it would look like. However, contour maps, topographic maps, are maps from above, meaning that we're above. So that's why I put these eyes up here. So what would this look like? You have to kind of think about what it would look like from above. And so if you saw these lines on a map, I want you to notice the distance, this distance from here to here, what that distance would look like horizontally. Okay. So let's look at a different example. So this hill has a much more gentle slope. Notice how far he has to travel left and right to go up 10 meters. Whereas before, he didn't have to travel very far to go up 10 meters. On this slope, he would have to travel a much further distance, horizontal different distance, to go up the 10 meters. So this would be something we would say is a gradual slope, a much easier, gentle slope to go up. So again, looking from above, if we look down, the difference from here to here is much greater than on this map from here to here. Okay? And we'll show you how that looks from above here in just a second. And then we have this slope over here on the left-hand side that notice that the rise here in the horizontal distance is much less. So again, looking from above, you would see this line here and this line here, which would mean that those lines would be much closer together. And again, we'll see an example of that here in just a minute. But if you compare the left side of this hill to the right side of the hill, notice to get from here to here, this horizontal difference is greater than this horizontal difference. So it kind of shows you the different slopes between a medium grade slope and a very steep slope here. Okay? So basically what we're doing is we're trying to get an overhead view of a landform to give us some idea as to what the slope or the steepness of the slope is in case we're trying to hike it or climb it. Okay, so this is a snip from a topographic map, and hopefully y'all recognize at least part of one of the words, the streets, and at least one of the streets in our vicinity, very close. So if you look here, there's a highway. This red line up here shows us there's a highway up here. This is a road. The name of that road starts with POTR, which you should be familiar with. And then this road right here is Dugas. Okay. So this road right here is Ellison. So for those of y'all that live in and around this area know, this is Ellison and this is Dugas. This little symbol right here shows us a school. So this is Stevens High School. This is Mernon Elementary right here. But I want you to notice that the topography here. So we see this closed circle. This is the top of a hill. So, and the elevation of this hill is 950 feet above sea level. But this line right here is 900 that comes around here. So if I were walking from here to here, I would start at 900 feet and I would be walking uphill to 950 feet. And each one of these lines represents a step in that walk, right? So if this were 900, this would be 910, 920, 930, 940, 950. Now, I know most of y'all weren't alive or old enough to know what this area looked like before Stevens existed, but this is where Pope John Paul back in 1986 gave a mass. And this whole area, when it was empty and there were no homes and no schools, literally was a big hill. So as I grew up in this neighborhood down here, Petrenko Road across the street was just a big hill right up here. But they've now built a neighborhood here and a school. And there's a big drainage ditch, which I'll show you here in just a minute, right here. This one should be even more familiar. If you look in, you might find the name of a street that you actually live on here. This is our neighborhood. So this symbol right here is a school again. So this is Pease. Up here is the alternative high school. So again, you can see some of the contour lines. So there's a hill right up here behind the school. And if you'll ever notice, if you've ever been on the football field, there's steps down towards the school. So the houses that are right here on Saddlebrook are way above our heads. So if we come out the back of the gym, we have the basketball courts and the retaining wall. So the football field is probably a good 8, 9, 10 feet above the basketball courts. And then if you go across the football field, there's another hill that goes up to the fence where the storage container is. And so this tells you right here that this is a hill. So this whole area of the neighborhood was built on a hill, and we would be going downhill if we were walking in this direction. Also notice the drainage ditch here behind that runs behind Saddlebrook is identified here with this blue line here as well. And then here's the duck pond over here as well. So you can see 850 feet here, 800 feet. So right up here, right at the very top of school, right where our storage container is here, the elevation here is about 850 feet. All right, so contour lines. Elevation is indicated by contour lines. So everywhere along this line is at 800 feet. Everywhere along this line is at 700. So there's a difference of about 100 here. So this map would actually be 720 feet, 740 feet, 60 feet, 780 feet, and then 800. So the contour interval, meaning the change in elevation from this line to this line, is 20 feet. So if I walked from here to here, I would be going up 20 feet. If I walked from here to here, I would be going up 100 feet. So a contour line is a line of equal elevation. All points on the contour line have the same elevation. Okay? 700 feet, 800 feet. So a couple of rules that we need to understand about contour lines. Contour lines will never cross. You cannot be, so for example, at this point right here, you cannot be at both 20 and 40 feet at the same time. So a contour line would never cross like this. Okay, there are times when other lines cross them, but those lines usually represent creeks or streams or rivers or roads. So this would be an accurate depiction of that. So we could not stand in a place where you would be both at 20 and 40 feet above sea level. All contour lines form closed loops, even if not shown on the map. So if we go back real quick, eventually somewhere these lines would connect. Okay, so this line would probably connect to this line would probably connect to this line, and this line would probably somewhere connect to that line, depending on the size of your map and the area that you're showing. So this, if you're looking at this would be a mountain basically, or a hill. Starting here at 0, probably an island around the ocean. And then if you were walking from here to here, you would be going up 5 feet, 10 feet, 15 feet, 20, 25, 30, and then 35 feet would be the maximum. Now, there may be some point in this circle that gets up to 36 or 37, 38 or 39, but nowhere, anywhere did you get all the way up to 40. Okay? Contour lines will always bend uphill when crossing a stream, and they'll never branch. So, for example, you'll see this V kind of shape in the contour line. Okay, that usually shows a valley or a stream or water would flow downhill, and so these V lines actually point uphill. Okay, so we'll get some practice with that as well. So the closer space the contour lines, the steeper the slope, and we talked about that early on when I showed you the pictures of those hills. So here, because the contour lines are really close together, that means you're changing your elevation, your altitude very quickly. Now, when we get over here and the contour lines are further apart, that means it's more of a gradual increase in altitude. Okay, so if we're looking, this would kind of be the profile of this line right here, where we'd have a gradual slope in this section right here. And then in this section right here, we would be going down pretty quick because these lines are really, really close to each other. Again, widely spaced contour lines mean more of a gentle slope. So again, if we're going downhill, these lines are really close together. So that represents a steep slope. But here, as we get to this section of the line, the contour lines get further and further apart, which means we have more of a gradual slope here. Okay. So here's a picture of an area. a topographic map of an area. You can see it's extremely busy, lots of contour lines, very close together that represent this mountain right here. So what this is showing you is this would be real life if you were walking from B to A, and then if this would be the map of that area. So if you were getting ready to travel to this area and go hiking, you would look at a map like this and know that this portion of the walk would be relatively flat because you're not crossing a lot of contour lines. But once you get to this point, you'd be crossing contour lines extremely quickly, which means your elevation or altitude would be changing really quickly. And that would be this section of the map here. Okay, again, contour intervals. Sometimes the map is going to tell you what the contour interval is. It could be 20 feet, it could be 40 feet, it could be 100 feet between each line. These are called index contours. Okay, they don't put the numbers on every single line because that would make the map super busy and harder to read. So you'll see something like this that says 700, and then this one is 800. So sometimes you'll have to determine what the breakdown would be for each line. So usually what I do is count the number of spaces, available spaces. So this is 1, 2, 3, 4, 5. So there's 5 spaces in between those two lines. So the difference between 700 and 800 is 100. 100 divided by 5 spaces is 20 feet. So the contour interval here would be 20 feet. 700, 720, 740, 760, 780, 800. Sometimes the scale at the bottom of the map will tell you what the contour interval is. We have to understand that this is how we would measure inches on a map and what that would equate to in real life, and so is it inches, 1 inch equals 10 kilometers or whatever it might be. You should have learned some map skills in 6th grade that tell you about that. But right here, it'll tell you what the contour interval is 40 feet. So a lot of maps will just come out and tell you what the contour interval is. Some you'll have to figure it out on your own. So this is your assignment for today. So what I want you to try to do is match this is the aerial view of us looking down on an area topographic map. And these are the profiles. So what I want you to try to do on the assignment, that's not on this one, but on the other document in Schoology, is you're going to match one. So you're looking at number 1 here. And so you're going to try to find, knowing that, looking at how closely spaced the contour lines are, meaning steep slope, and then a gradual slope over here, which one of these pictures would be represented by this map. And so you have an answer document or an answer column over here on your assignment where you would put in, if you think, C is 1, you would put C next to 1. If you think 4 is D, 6 is B. So you're going to try to match up these profiles. This is the side view with the aerial view or the topographic map. Okay, so that is your practice assignment for today. All right, guys? All right, let me know if you have any questions.